345. And here are the two basic shapes of your exponential graph. And I'll get you to draw a dotted line in if you have your red pen for asymptotes. At y equals 0. And they've done it generally. They say if you have a to the x, an exponential function is a function where you have a to the x and a is some positive number. If that a is bigger than 1, it's going to increase. If that a value is between 0 and 1, it's going to decrease. So I find that it's nice to have a general graph, but sometimes it's a lot easier if you actually have normal examples. And so let's draw the graph of 3 to the x, and let's draw the graph of 1/5 to the x. And then let's do a little analysis of both of those graphs. On the 3 to the x graph, I labeled 0, 1, I labeled 1, 3, I also labeled 2, 9, but it would be enough just to label 2 points. 2 points and the asymptote, and having the shape increasing is your general exponential graph. For the 1/5 one, label 0, 1, 1, 1/5, have your asymptote, and because it's going down, this would be decreasing. Now, it's kind of interesting, in the 1/5 one, would you agree that this is 1/5 to the 1? I don't have to write that little exponent, but I could. And then if I played around with my exponent rules, 1/5 is the same as 5 to the -1, moving that exponent up to the top. And then my exponent rules say if you have a power to a power, you can multiply them. So this graph, which is 1/5 x, is exactly the same as y equals 5 to the -x. Now 5 to the positive x, can you see would look very much like our 3 to the x graph on the left. It just would have 1, 5 instead of 1, 3. If you think of transformations, what does a negative do when it's beside the x? What kind of reflection? Horizontal reflection. Can you see that if you took this one and flipped it, it would look like this one? And so that's why our fraction ones are decreasing, because technically they're just a regular one with a negative flip in it already. So if you were first going to graph this, the things that I would graph, always put in the point 0, 1, because you plug in 0 for x, anything to exponent 0 is 1. And if you plugged in 1, wow, here, I can say that. You'd get 1, 1/3. And this would look like this as a result. Then you can put in your asymptote. With your asymptote in place, every time your x increases by 1, so if I increase my x by 1, I would have the point 2, 1/9. That means you're multiplying your y by 1/3. Every time x goes up by 1, you multiply y by 1/3. This graph is decreasing because it's going down from left to right. It has a y-intercept at 0, 1, but no x-intercepts because of that asymptote there. It never crosses the x-axis.
A question. Can that ever change that it's 0.1?
From 0, 1? Well, we're going to take this and do our entire grid, move it up, down, so things can change if you stretch it. But the base graph always has 0, 1. So we're looking at the very beginning one. Domain here is everything, and your range is the y values are bigger than 0. You can write it that way, or with round brackets, you could write it this way. Questions for practice? 3, 5, and 7.